Students, so today we are going to discuss last topic of second chapter. It contains reverse osmosis and abnormal molar masses. So abnormal molar masses, they are explained on the basis of Hoff factor. Now first of all, reverse osmosis. Now if we reverse the direction of osmosis, means what is the definition of osmosis? It is the flow of solvent molecules from pure solvent to the solution. Now if we reverse this, means solvent molecules start moving from the solution to pure solvent, then it will be termed as reverse osmosis. Now is it possible? Yes, it is possible. How it is possible? Since we have discussed earlier osmotic pressure, if we apply pressure more than osmotic pressure to which side? To the side of solution, then what will happen? Solvent molecules will start moving through the semi-permeable membrane. Okay, so this will be termed as reverse osmosis. Now a very good example of reverse osmosis is desalination of sea water. Desalination means removal of, D stands for removal of salt from the sea water. So for this particular process we use reverse osmosis. So what we do, we apply pressure more than osmotic pressure on the side of salt solution, or we will say sea water, and then what happens? Water which is pure, that squeezes out of the sea water through the SPM, semi permeable membrane. Okay, now see, from this diagram you can see it very properly. This is semi permeable membrane, this one is semi permeable membrane, and now what we are doing, we are applying pressure here on sea water. Okay, now this SPM will allow the movement of solvent molecules, as we have discussed that only solvent molecules can move from salt water or sea water, or through, they can move through SPM. So from salt water, solvent molecules will start moving towards the other side, and on the other side we will get only water. Only water means it is fresh water. So here the process used is reverse osmosis. Okay, so which type of SPM is to be used? Now see, since the pressure required is very high, okay, so it should be something which can bear that pressure. So we use a porous semi permeable membrane made up of cellulose acetate, okay, and that is also supported on a suitable substance. Okay, so this particular layer or film is permeable to water. Permeable means it permits the movement of water molecules, and it is impermeable. Impermeable means it does not allow the impurities. Now what are impurities here? Except water molecules, all other things are impurities. Okay, they are solute particles, so they do not move through this. Now next topic is abnormal molar masses. Now see, what do we mean by abnormal molar masses? When we are using colligative properties and we are calculating the molecular mass, then if we know the solute, then we know what should be the value of molecular mass. Now if the calculated value is not nearby the expected value, then that is termed as abnormal molar mass. Okay, now by using the colligative properties, why we are getting abnormal molecular masses? What is the reason? So there are two reasons. One reason is dissociation of solute particles or association of solute particles. Now how these things are related, let us discuss. We know that ionic compounds when dissolved in water dissociate into cations and anions. Okay, any ionic compound that will form cation and anion when we are putting it in water. Now suppose we have taken KCl. If we calculate its molar mass, then it is 74.5 gram. Okay. Now when we put it in water, it will form K positive and Cl negative ions. Okay. Now if we ignore inter-ionic attractions, because water is also polar and KCl is also giving ions, so there will be electrostatic forces of attraction. So suppose we are ignoring those forces, then 1 mole of KCl in 1 kg of water would be expected to increase the boiling point by this much amount. Okay, this is elevation in boiling point which you have studied. So if we are taking this much amount in this much solvent, then this much is expected that this much boiling point should increase. Okay. Now if we don't know about the degree of dissociation means that how many molecules get dissociated. Okay. Then if we calculate by applying the formula, then we will come to a conclusion that molecular mass of solute is near about 37.25. Okay, this may be our result by using elevation and boiling point property. So what we are getting, it should be 74.5, but it has come 37.25 gram. So we will say that there is abnormality in molecular mass. Okay. So how it happens? It happens because of dissociation. So it means when there is dissociation of solute into ions, the experimentally determined molecular mass is always lower than the true value. Okay. So this is due to dissociation. Now due to association, what happens? Okay. Now let us consider ethanoic acid. Ethanoic acid forms dimer. This is called dimer. Okay, 2 molecules we have taken and 1 molecule we are getting. Why we get so? Because of hydrogen bonding. These are hydrogen bonds. Okay. Now how it goes? Molecules of ethanoic acid dimerize in benzene due to hydrogen bonding. Now benzene is solvent here, this is solute here. Okay, so due to hydrogen bonding, they form a dimer. Okay, in this case, the number of particles is reduced due to dimerization. Okay, now see, colligative properties, we know that those properties depend on number of molecules of solute. Now when there is dimer formation, so it means if we were having 10 molecules, then now we are having only 5 molecules. So these properties depends on number. So what will happen? Whatever we will get the value of colligative property, that will be more than our expected value. Okay. So because of this reason, the normal value, the expected or normal value, the molecular mass that is either lower or higher than the expected or normal value is called abnormal molar mass. Now see, the way we got in dissociation, what we got in dissociation, determined molecular mass that was lower. Okay, so whenever dissociation occurs, determined molar mass is lower, but when this association occurs, then due to association, the determined molar mass value is higher. Okay. So these values which are either higher or lower than the expected values, they are known as abnormal molecular masses. Okay. Now how to counter these abnormal molecular masses? So for countering this, there is a factor called Hoff factor. Now Van Hoff is the name of scientist. This factor is noted by I. Okay. Now what is I, or what is Van Hoff factor? I is equal to normal molar mass over abnormal molar mass. Or we can say, since colligative properties and molar masses, they are colligative property and molecular mass of solute, they are inversely proportional to each other. Okay, in any property you can see. So what we do, if we don't want to write molar mass, then we can write like this: observed colligative property over calculated colligative property. Okay. Now how to find the value of I from association or dissociation? So for finding I value, we can apply this formula: total number of moles of particles after association divided by total number of moles of particles before association. This way it will give us a number. Okay. Now see, just like for in this case, total number of particles after dissociation, after association, they are 1, and total number of particles before association were 2. So I value in this case will be 1 by 2. Okay. Similarly, for dissociation, what is there? KCl gives K positive plus Cl negative. So I in that case will be 2 divided by 1, means 2. So from here, what result we can draw? The value of Van Hoff factor I is greater than 1 if solute undergoes dissociation, and this value is I value is less than 1 if solute undergoes association. So this is very important question which is asked many times. So this you have to remember. Now see, if we have to involve Van Hoff factor, then whatever we have deduced the relations in case of colligative properties, we have to just put I on the right side. So just like elevation and boiling point was delta TB is equal to kbm, we will be writing I kbm. Delta TF is I kfm. Pi is equal to I crt. Okay. So now I value we have to consider if in our question it is given that solute undergoes dissociation or association. Okay, that can be calculated easily from this relation. Okay. Now let us solve this numerical. So in this numerical, what is there? 2 gram of benzoic acid dissolved in 25 gram of benzene shows a depression and freezing point equal to 1.62 Kelvin. Molar depression constant for benzene is 4.9 Kelvin kg per mole. What is the percentage association of acid if it forms dimer in solution? So first of all, from the given data, we are given weight of solute, Kf value, weight of solvent, and delta Tf value. From this, we will calculate the value of molecular mass of solute. So calculated value is 241.98. Okay, this is experimental molar mass value. Now, if we see the formula of benzoic acid, then its molecular mass value is 122. See, here we are getting 241.98, and normally from the formula its value is 122 gram per mole, or we can say just 122. Okay. Now how to use this data? Now see, in case of benzoic acid there is association. Now suppose degree of association is X and 1 mole is in the beginning. Out of 1 mole, X amount or X moles, they undergo association. Then what will happen? This was initial concentration. Out of this, X moles have associated. So how many moles are left? 1 minus X. Now see, since there is formation of dimer, so how many are formed? The formed dimers will be equal to x by 2. Okay, formed dimers will be equal to x by 2. Now what we are getting? When equilibrium is obtained, then 1 minus x is the number of moles of reactants and x by 2 is the number of moles of products. So total number of moles after equilibrium will be equal to 1 minus x plus x by 2. So it will result in 1 minus x by 2. Okay. Now I value is this much. This is the formula. From here we will calculate the value of I. Okay. Now this is okay. Now see, don't confuse here what we have done. You know that I is equal to total number of moles which have associated or dissociated divided by total number of moles in the beginning. Okay, total number of moles after association or dissociation divided by total number of moles in the beginning. Now how can we write here? I is equal to total number of moles we have calculated 1 minus x by 2. Okay, and how many total moles were there in the beginning? It was 1. So I is equal to 1 minus x by 2. Okay, here 1 minus x by 2 is total number of molecules after association, and what is 1? Total number of molecules in the beginning. Okay, so I is equal to 1 minus x by 2. Now I value we have calculated, and from this we will calculate the value of x. So if we rearrange, then x value comes out to be 0.992. So 0.992 can be written as 99.2%. So this becomes the degree of association in case of benzene, not benzene, benzoic acid. Now on the basis of whatever we have studied, you have to solve these home assignments. Okay, thank you.